Good evening, everyone. So let me begin by introducing myself. My name is Niyati, and I work in the logic optimization group. I primarily focus on software architecture and algorithm design. Outside of work, I enjoy weightlifting and traveling, and doing what I love, both at work and outside, is what makes me a girl geek. So let me start by asking you all a question. How many of you here are hardware engineers? And how many are software engineers? Perfect. So as we can see right in this room, we have a range of distribution of engineers from hardware background and software background. And that, I believe, presents the direction in which Xilinx has been headed. Traditionally, Xilinx is a semiconductor and FPGA chip company, and most of our customers used to be hardware developers. But as we have moved into the data center and acceleration markets, more of our customers are coming from software backgrounds. And what I'd like to do today is give you an overview of the tools that we have that help our developers, regardless of their background, use our FPGAs to run their designs. So we have the hardware developers who code using RTL, Verilog, VHDL. And for them, we have our signature product, which is the Vivado design suite. Next, we have our hardware-aware system developers, software developers, who use C, C++, and System-C, and for them, we provide the Vivado HLS compiler. We also have our software application developers who tend to use FPGAs mostly for accelerating their products or their designs, and for them, we have the SDAccel environment. And finally, for our data scientists who use frameworks such as Caffe and TensorFlow, we have the AI compilers or edge compilers. In the next few slides, I'm going to go into a little bit more detail onto each of these different tools so that you can get an idea of how they meet the needs of the targeted developers. So as I mentioned, most of our hardware engineers work with RTL, Verilog, VHDL, but the FPGA is a piece of hardware and it's only going to understand binary numbers or bit stream. And so we have to take the RTL through a process to generate that bit stream. And the best analogy I can give is kind of a translator. So if you and your neighbor were to speak in, say, different languages, then the translator will go from your language and convert it into a language that your neighbor can understand. And so we take the RTL through a similar process. We start with synthesis. So there's the RTL, we apply synthesis, and the job of synthesis is to create a logical netlist, which is technology mapped to the targeted FPGA. Once that is complete, then we need to optimize the netlist, and that's where I come in. My team and I work on optimizing the logical netlist. We've optimized the design for power, area, timing, depending on the developer need. And finally, create an optimized netlist, which will better use the resources that are on the FPGA. Once that part is complete, we run placement. And the placement essentially takes these logical blocks here and puts them on physical locations on the FPGA. Finally, we have the router, which connects those physical blocks together. And after placement and routing are complete, we have a bit stream that we load onto the FPGA to run the design. Now, instead of starting in RTL, if our developers were to start, say, with C, C++, or System-C, then an additional step gets added because we have to first convert those languages to RTL before they can be fed into the backend tools. And that's where our Vivado HLS compiler steps in. The HLS compiler provides an Eclipse ID and allows our customers to design and develop using our products. The Vivado HLS compiler can be thought of as sitting on top of the Vivado design suite. So once the C++ is converted into RTL, then we feed it into the Vivado design suite and generate a bit stream. And that allows us to provide a comprehensive solution for people starting with C, C++, or System-C. Now, so far, the tools I've talked about address the needs of our hardware developers. But for our software application developers, we also have a tool, which is our SDAccel environment. The SDAccel environment and compiler sits on top of the existing Vivado HLS compiler and the Vivado design suite, and allow users with no FPGA background, no hardware expertise, to take their designs and run them on our FPGAs. They also allow us to support heterogeneous applications. So most of our software application developers are trying to accelerate their designs using the FPGAs. And so the designs will have a software component and they will have a hardware component. And the best example I can give you is that of computer vision. So I'm sure some of you have security cameras at home. And in that case, you know that there are multiple parts to that. There is recording, live video, but there's also object detection. where it will tell you that your dog is running around or there is a robber in your house. And in that case, the object detection part is what gets accelerated using hardware. The SDAccel environment provides multiple different tools to our customers. We have a debugger, profiler, libraries ranging all the way from low-level math libraries to high-performing DSP libraries. But the star of the show is the compiler. The compiler helps us provide a comprehensive solution for both the software parts and for the hardware parts. The compiler compiles the software part so that it can be ran on the x86 machine, and it compiles all the individual hardware components, the kernels, so that they can go onto the FPGA. The kernels are compiled using the XOCC compiler, which internally leverages the Vivado HLS compiler and the Vivado design suite to generate bitstream for the parts that need to be accelerated. So once the compilation is complete, then the software part will run on the host x86 machine, whereas the hardware part, which are the kernels, will run on the FPGA, and they will communicate with each other using our Xilinx runtime tools. Now, this SDAccel environment and compilers are very crucial and critical building blocks in our next set of compilers, which are aimed towards our data scientists who provide us models in frameworks such as Caffe and TensorFlow. Our AI compilers, they tend to, the object here is to take the models that the customers have provided and optimize them with deep neural network pruning and quantization so that we can get optimized models. And these optimized models are then targeted using our SDAccel compiler so that they can go into the FPGA and generate a bitstream. Finally, we have our AI compilers, which provides for Python interfaces, and so we can integrate very easily with the Caffe and TensorFlow frameworks. What I would like to leave you with today is that regardless of your background, whether it be software, hardware, or anything in between, we at Xilinx have a tool that will allow you to take your design and run it on our FPGAs easily and efficiently. Thank you.